Alright, so today we are going to be learning how to convert shapes from SOLIDWORKS and converting that over into Mastercam. So in this case here we just have a simple IQ tester that we've made previously, and we're going to want to take this and bring it over into Mastercam so that we can use the CNC router in order to cut this out of a piece of stock. So our first step after we've actually completed this project, we're going to go to our tools pattern and then go into Mastercam Direct and select Mastercam. When we do that, we're going to get this window to the left to pop up. We want to make sure that in our options we have Import Operations and Create Edge Curves checked on, and then we're good to select the green checkbox. Converting this over into Mastercam should only take a minute or so. If it takes any longer, just be patient. Alright, so once this has loaded up into Mastercam, this window should go away in just a moment. And we should be getting a window popping up just over on the left of our screen over here. There we go. So once this comes up, you can just press cancel. We don't need to open or save anything right now. And you'll notice that our shape that we created in SOLIDWORKS is just over here. In order to position that, we can just press right click on our mouse, and we have this fit button here. You'll also notice that there's different view options that we can select here if you need to mess around with the view of your object afterwards. But for now, we're just going to select fit. Now, the first thing that we're going to do here is we're going to go up to the top of our screen and go to Machine. In Machine, you're going to come over to the left and select Router, and you're going to select the Larkin Cam tool. The reason we need to select this one here is because the Larkin is the CNC that we have out in the lab, whereas the default is not the one that we will be using. So we're going to click this one here. This is then going to add that machine group. So we can delete the default that was automatically added there. In order to do that, we're just going to press either the delete key or the suppress key on your keyboard. And that should get rid of it there. So the first thing we're going to do with our shape here now is select the stock setup. So in order to do that, you're going to go to Properties, press the plus key that I just selected there, go to Stock Setup. Once that loads, you're going to press this button here, which is the Create Rectangular Stock. This is because we're going to be using a piece of wood, which is going to be rectangular. So you want to make sure that after you select your rectangular stock, that everything that you've made in SOLIDWORKS as a part of your shape is highlighted yellow. Once that's done, you can press Enter, and it should give you the dimensions of your shape. In this case, we have a 5 by 5 by 3/4 of an inch piece of stock here. You can move it using your roll wheel, and we know that we're good here. Another thing to note with your stock setup is your Z. If your Z is any more than 0, it means that you extruded it outwards instead of back in SOLIDWORKS, so you'll have to go back and fix that. So other than this, all of our dimensions look good. Another thing to note while you're in this window here is that what unit you're in down in this bottom right corner. In this case, we're in inches, so we're all good. We can just press check. And we're ready to move on to our tool paths. So the first one we're going to work with is drill. We're going to use drill for all of these tiny peg circles that we need to cut out of our shape. Up in the top left, we have all of our tool paths. We're just going to select this drill one here. This is then going to open this window here. We want to select this tool here called Mask on Arc. We're going to select one of the circles and then highlight our whole shape, and this should highlight all the circles that are the same size. This means that we can now drill all of them in just the one toolpath instead of having to go back and re-click every single one of these holes. Okay, so now that all these are selected, we want to make a more efficient toolpath instead of this big mess. So we're going to go into selected order, and we are going to select this one here. So we're going to start in the bottom left corner and just go in this zigzag motion here. After that, we're done, and we're going to get this pop-up window. We know that we're in drill because you'll see that the toolpath is highlighted in gray, so we know we're working with the right tools. We're first going to pick what bit we want to use. In order to do that, we're going to go down to our select tool from the library. The bit that we want to use is going to be number 145, which is a 1/4 straight bit. Once we have that selected from the library, we're going to press OK and make sure that it's highlighted in this library here so we know that it's selected. Okay, we're then going to go to linking parameters, and we're only concerned with depth here. There's nothing else that we need to do in this library. So we're going to set our depth to 0.375. We want to make sure that's negative so that our drill bit is going down into these holes over here, and the 375 is just converted into an eighth. And we are good from there. You'll notice that it looks like this on our sheet. We can just go to this tool here, which is just verify selected operations. If you click this, it's going to bring up this short video that you can watch to make sure that you've done everything correctly so far. So we can slow this down slightly, and you'll notice our drill bit going in, drilling them all, and we know that we're okay to move on to our next step. Okay, once we have our drill done, we can move on to our pocket tool. So from here, we want to make sure that we have wireframe as well as C-plane selected and chain. Once we have that done, we want to go over to our pocket here, or our big circle, and we're going to make sure that the top circle is selected. Okay, if you select the bottom circle, it's going to cause the bit to drill all the way down through this circle and then try and cut out this 1/2 inch in one go. And if all of your other steps were set up correctly, it would then drill an extra 1/2 inch down into the table, which we don't want. You'll likely break the bit and also ruin your project. So we want to make sure that our green arrow here is going clockwise. Once all of these are set up, we're just going to press OK. We're again going to get this window show up here on the left. We want to make sure that pocket is highlighted in gray. Tool, we want to make sure that we have that 1/4 straight bit selected once again. After that, we don't have to do anything with holder, cut parameters we don't have to do anything with. The first one that we have to do something with is roughing. In roughing, we're going to select true spiral. So this is the pattern that the pocket is going to be cut out in. Where it's a circle, true spiral is the easiest. And we are good with this here. Entry motion we want to make sure is turned off. Then we're going to move on to finishing. In finishing, we want to make sure that the machine finish pass is only at the final depth. This just shortens the amount of time that the CNC has to cut this pocket. If we were to finish after every pass, it would go down a 1/4 or an 1/8 of an inch, go all the way around, and then go all the way around again to finish that cut, and do that for every step that it needed to do. Alright, so we're good there. We don't need lead out or lead in, lead out on. We do need depth cuts turned on because this is the amount of steps it's going to take in order to get down to this 1/2 inch. For our depth cuts, we're going to make it an 1/8, which is 0.125. Our next step is to go to linking parameters. Here, the only one that we're concerned with is the depth, just like we were when drilling. We're going to make sure absolute is turned on, and the depth we want here is going to be a negative 0.5 or half of an inch. The negative, again, is used to indicate that we are drilling down into the stock. Okay, everything else here looks good. We should be good to just press this OK button down here. And you'll notice that this is the tool path that our bit will be following. Again, we can just press the Verify Selected Operations. Press play. And our pocket is all good. Okay, we can move on to our final tool path, which is going to be our contour. We're just going to click this drop-down menu here and press this first one up on our left. Again, just like we did with our pocket, we want to make sure that wireframe is selected, C-plane is selected, chain, and we are again in the correct tool. Okay, from here we want to click the top right corner, and we want to make sure that our arrow is going clockwise. We also want to make sure that we're on the top edge, not the bottom edge, as again, like with the pocket, we would be drilling down through to this line as our starting point and then going an additional distance, which we don't want. From here we are good. Again, our contour is highlighted in gray, so we know that that is correct. We're going to go to our tool, highlight our quarter straight bit. We don't need anything for our holder. Our cut parameters we don't have to worry about. Depth cuts, again, we are going to turn on, and we're going to make it 1/8 of an inch once again. Lead in, lead out, we're again going to turn off. Tabs is probably the most important part of this contour step, as the tabs is what is going to make sure that the stock does not fly out of its original casing or stock that it's being cut out of. So the tabs actually hold it in place. So we want our tabs to be set manually because we want to be able to set where they're to. So we are going to position these after we change these ramp moves to vertical moves. We want our tabs to be straight up and down. This has to do with the type of CNC that we have here. Some CNCs are able to use ramps, however, the one that we will be using in class will be a vertical one. So we can now position these. Again, you want to make sure that you're clicking on the top. I'm just going to put mine to the sides. You want to click, and they will disappear. However, once you press enter, you'll be back to your home screen and your tabs should be there. The tab thickness we are going to change to be 1 inch, or 1/8 of an inch, sorry, to make sure that that's thick enough to actually hold our piece of stock and it's not flimsy. Okay, so again, we should be good there. We're then going to go to linking parameters once again, but now we're going to set our depth to a negative 0.8 inches. The depth of our actual stock is 0.75 inches. However, by making it a couple quarters of an inch bigger than or deeper than what our stock actually is, we're able to make sure that it absolutely is being cleanly cut out of the stock. All right, so from there, everything is good over here. We can press OK. You can see on the sides that we have our tab placed over here as well as over here, but just to make sure, we can again watch our processing video, and we see the bit go around, finishing our product, and here's the tabs that we just made. Once everything is done here, all of the tool paths are completed, and you've made sure that all of your tool paths are correctly done, you can then go to this button up here, which is Post Selected Operations, This is going to convert what you've just done into a G code, which you will then be able to put onto a flash drive, hook up to the computer that is associated with the Larkin, and you will then be able to cut your stock. So all you need to do after you bring up this post-processing is just press OK. Save it as a recognizable file. So in this case, I will save mine as IQ tester tutorial. Put it somewhere that I know. In this case, I'm going to put it in this file here with my documents. I'm going to press save. And you should then be able to see the actual G code that comes up once you finish your project. So that's everything that is required for making this IQ tester and converting it from SolidWorks to Mastercam. Hopefully this was helpful, and